Okay, so quick review on area and volume. So first example, let R be the region bounded by y equals e to the negative x2 the y-axis, and x equals 1. So just visualize it, and the x-axis. Okay, that's my solid. That's my region. Sorry, I'm going to rotate it. So find the volume of the solid obtained by rotating R. Let's write R. Okay, rotating R about the y-axis. Okay, so let's draw the graph. So we're doing the graph here. So we're rotating around the y-axis. So I'm going to draw it like this. Okay, so this function, e to the negative x2, how do I draw this? So I don't know how to draw it, but when I don't know how to draw a function, I just go with the limit cases and see if I could find some key points, okay? So x equals 0, that would be at 1, for sure. And as x goes to infinity, this is e power negative infinity, so it's getting close to 0. So, and it's always positive, right? E to the anything is positive. So it's above the x-axis, goes at 1. When it's 0, it's 1, and at infinity goes to 0. Same thing if we go to minus infinity, by the way. Even negative infinity square is infinity, negative, so it's 0 also. Okay, so it will look some sort of like this. Okay, I'm interested in just between 0 and 1, right? Because it stops at x equals 1, and the y-axis and the x-axis. So basically, this is my region. Okay, that I'm rotating about the y-axis. Okay, any questions on the setup? Okay, so this is messed up. So I'm gonna just represent it on the other side here. So it will look something like this. There we go. And which method would you use here?
Cylindrical shell.
Very nice. I would use a cylindrical shell as well. So take any x here, go like this, rotate it. This bar will appear here, and you will form a cylinder when it rotates. Exactly. Sorry. Okay, that's it. So now I need to find my measurements. My radius, of course, is x, and my height is just the value of the function, so e to the negative x2. And now I could find my area. So the lateral area of this cylinder is 2 pi radius height. And so the volume will be the integral from 0 until 1 of this total area here, of this lateral area, 2 pi x e negative x2 dx. Okay, and this should be an easy one. Okay, because as you see, the substitution is direct. U equals negative x2, and you will find negative 2x. Okay, let's do it. Let's solve it. The next question, I'm not going to ask you to solve the integral to evaluate it, but just to set it up. Okay, so let's do the substitution. U is equal to, let's say, negative x2, and so du is negative 2x dx, and so x dx, or actually 2x dx, might as well, since I have a 2 here. So 2x dx is equal to negative du over 2. Okay.
So why is it over 2?
No, you're right. There's no negative. No one over 2. 100%. Thank you. I'm used to isolating x dx. You're right. Perfect. And so it will be the integral, so pi, so e to the u times x dx, 2x dx, sorry, which is negative du, from 0 to 1. Are you okay with this?
Why is it 0 to 1?
Oh, very good. What should I do?
I should change the...
Okay, very good. Okay, you were very fast. Okay, I was expecting a little more time that I was going to slip this one through. Okay, so be careful. Okay, you need to change the bounds. You did a substitution, a change of variables. You change from dx to du. The bounds change. Okay, so for those of you who caught it, very nice.
No, but I was talking about the...
Oh, you weren't talking about that?
Yeah.
What were we talking about?
At the beginning of this, the v equals the integral of 0 to 1.
Okay.
Why is it 0 to 1?
Oh, because the x. Oh, I thought
Yeah. It's okay.
Okay. 0 to 1 because x, I'm taking it here. Okay, so x is any value here. It stops at 1. You understand? It starts at 0, ends at 1.
Okay.
You don't need to go further, or else you're continuing your area, your region. But the region stops here, so you have to stop at x1, at x at 1. Okay, but somebody else spoke about the bounds here. So what are my bounds? When x is 0, u is 0. And when x is 1, u is negative 1. You okay with this?
Yes, sir. Sir?
I'm listening.
Oh, how did you find 2 pi x again? I'm sorry, I wasn't looking when you mentioned it.
This here? Okay, so this is the lateral area of this cylinder. I'm going to draw the cylinder here. Okay, so this cylinder, let me make it like this. Okay, that's my cylinder. Okay. So the dimensions of the cylinder, so this you're okay that it's x, and this you're okay that it's e to the negative x2. You okay with that?
Yeah.
Okay, so now I need the lateral area. So the lateral area here is 2 pi times the radius times the height. Right? Lateral area of any prism is always the perimeter of the base times the height, always.
Oh, okay, yeah, I see.
Okay, perimeter of base, which in this case it's a circle, so it's the circumference of the circle times the height. And so the r is in my case x, and the height in my case is this.
But why are we finding the lateral area instead of the volume of the cylinder here?
No, you don't need the volume of the cylinder, you need just the shell. We said it's a cylindrical shell, that means we're just taking a little thin layer around the cylinder. And then the next cylinder, I'm going to take another layer. And if I add all these layers, it's going to fill the whole solid. You can't take the volume of the cylinder, because if you're adding volume, then you're going to count the volume inside a million times.
Yeah.
Okay,
Yeah,
so
you're
just layers. Okay, just the shell. It's called the shell.
Sir?
Yep.
There's someone in the waiting room.
Oh, thank you. Okay, does that answer your questions? I just need now to evaluate this integral. That's a very easy. E power u is just e power u, and negative pi is a constant. So this will be equal to negative pi e to the u evaluated from 0 to -1. Okay, and then I plug in -1 inside, and so I get negative pi e to the -1, and I get a negative volume. Is that possible? How could that be?
Because you're going from 0 to -1, but you have to go from -1 to 0.
No, I did look at my steps. Nothing's wrong. The -1 came from my substitution. That's fair. That's legal. Everything's legal here. What happened?
Don't you have to replace the u?
Sorry?
Don't you have to replace the u by minus x to the 2?
Don't you have no? Why is that?
I thought you had to replace it.
I'm sorry, I can't hear you well. Sorry.
I thought we had to replace it.
No, I'll replace it back by -x2 here.
Yeah.
No, because I already changed my bounds. I need to go back to my x2 and then replace the bound to 0, 1. I don't need to do that. I changed my bound so that I could evaluate right away. So what went wrong? Okay, I'm going to tell you, nothing went wrong. The only thing we didn't do is that when you evaluate, you have to evaluate at -1 and at 0. So minus, when you evaluate it at 0, you get negative pi times e to the 0, which is 1. Okay, it's just that we're so used to when we have a 0 here that we don't even plug it in, that we think it's 0. But in this case, since it's e power 0, it's 1. And so that gives me a value here. Okay, so it's a silly mistake, but I've seen it a lot, and that's what I'm doing it here, so to highlight it for you. All right, so my answer here will be pi times 1 minus e to the -1. Okay, and that's a positive value. Okay, so another example. Let R be the region bounded by, so I prepared one here. What was it? X equals -y2 plus 6y minus 4 and y equals x. Okay, find the volume of the solid obtained by rotating r about, so 2. First of all, let's say x is equal to -1. And second, y equals 5. Okay, so here what I want, I don't want you to evaluate, just set up the integral. Okay, no need to evaluate. It's going to end up being an easy integral that's just going to take time for nothing. Okay, so the first thing we do is, of course, we draw these two regions, these two curves, and find the region. So I'm going to go like this. So how do you find the region? So I need to find the intersection points. Okay, so I know that this is a parabola open to the left, and I know that this is the y equals x line. Okay, so the intersection so make them equal to each other. So y equals x, so y equals -y2 plus 6y minus 4. Send everything to the left side. y2 minus 5y plus 4 equals 0. So y minus 4 times y minus 1 equals 0. So y equals 4 or y equals 1. Okay, which means x is 4 and x is 1, since x equals y. Okay, so I have a straight line like this, y equals x, and apparently they intersect at 1, 1, and 4, 4, and it's a parabola open to the left, so it looks something like this. Okay, you don't need to be very precise. Just know what's important is that they intersect at 1 and at 4. Okay, so y is 1 here and y is 4 here.
How did you get the intersection points? Like, you put y equals -y squared plus 6y minus 4?
Yeah.
But wasn't it x equals?
No, the x, so x is equal to y, and also x is equal to that. So they're equal to each other.
Okay.
Okay, very good. And now I'm going to rotate around the x equals -1 line. This is my axis of rotation here. So again, I just want you to set up the integral. I don't need you to evaluate it. Okay, so if I rotate here, so I will get something like that. 1, so more or less. Okay, so let's say, so this and there we go. Okay. This is x equals y and -y2, do I have space to write? -y2 plus 6y minus 4. And this is x equals to y. So which method do you suggest that we use here? This is a big question now. What do you recommend?
This
What did you say? What did you say?
The
Washer
shell.
method.
Washer. Okay. Who says shell? Okay. So definitely a washer here. Okay, because if you would to do a shell, then you would set up an x here. Look how complicated it would be. You would set up an x, so you would have to do top minus bottom to find the height of your cylinder. And as you see, top function minus bottom, top minus bottom, they're different. You have to change at 4. You have to change. You have to find the vertex here because the x goes all the way to the vertex. You have to find it and separate into two integral. 1 to 4, 4 to the x of the vertex. That's one problem. Second problem, you have to express this function here, this relation, the parabola here, as a top function, bottom function in terms of x. So we'll have to isolate x here. That's very complicated. That's really annoying. Okay, it's doable, but it's really complicated for nothing. So you're better off in this case just taking a y here and taking a slice like this and doing a washer. Much simpler. Okay, sorry, it's really messy. Okay. Let me draw my washer on the side. Okay, what is my, so you help me out here. What is my big radius and what is my small radius?
The big
Buddy?
one would be the
Big radius is what? Remember, everything's going to be in terms of y, yeah?
so it would be the minus y squared plus 6y minus y.
Yes.
Not the big radius.
So minus, very good. So it's really the x here. This x, that's the big radius. Okay, but the x is actually negative y2 plus 6y minus 4. Plus 1, right? This is the x plus the 1 here.
Is that y or 4?
That's a 4. So,
Okay.
Sir,
yes,
could you explain why there's +1, please?
yeah, because this until here is x, and this is 1. It's always the distance between x and the axis of rotation. X is from 0 to x, and then from -1 to 0, you have 1 there. That's why you have to add 1 to the radius.
Okay, thank you.
Okay, and same thing for the small radius, which stops at this function, and this would be y plus 1. Okay, so what is the area of this washer, okay, of this ring here? Pi times big radius squared, so negative y2 plus 6y minus 3 squared minus the inner disk, pi times y plus 1 squared. And now I could set up my volume integral. V is, so the integral y goes from what to what? 1 to 4, from 1 to 4 y of this. So I'm going to take out the pi, negative y2 plus 6y minus 3 squared minus y plus 1 squared, and all this times dy. This is the integral that will give you the volume of that solid. Okay, second one. So this is done. Second one, let's redraw the same shape, okay, same region, and I'll do it here this time. So again, y equals x, 1, 4, and something like this. And then this is 4, 4. I'm rotating around y equals 5. Okay, so this will appear up here, and all the vertex here will appear up here, say, and this will up here. It's a bit weird, see? Okay, whatever. It's a bit crooked, but more or less. Okay, so which method would you use now?
Disk washer.
Disk washer again. No, not disk washer. I mean cylindrical shell here. Because now, yeah, the idea is everything is already in terms of y. Okay, so x equals negative y2, no space. Just put it below here. X equals negative y2 plus 6y minus 4. And this is y equals x. Okay, so I'm rotating around here. Everything is in terms of y, so might as well my thickness should be in y's. If I do a washer, then I'm putting a cross section here, and I have to express everything in terms of x. Okay, because my delta x will be the thickness of the washer. Here, if I'm putting a y here, my thickness is a delta y. Okay, my layer has a very thin thickness that I'm rotating. And it's going to appear here. And so that's going to be my cylinder. That's the cylinder. Okay, let me draw it here. Draw my cylinder up here, and then we'll be done. I'm going to need the radius. What is the radius? And I'm going to need the height. What's the radius here?
Five minus y.
Very good. What did you say? 5 minus y?
Yeah.
Perfect. 5 minus y is very good. Okay, my radius is from here until here. Okay, this is y. This is 5, so that's 5 minus y. Perfect. And what is my height? Right function minus left function. Okay, so my height will be negative y2 minus 6y. This, so this minus x. So sorry. Minus y, sorry, did I mess up? It's plus here. Okay, that's what I say. It's going crazy here. Plus. Okay, so minus 5y minus 4.
Isn't it like plus 5y?
Yeah, plus 5y. Perfect. Yeah, thank you. Plus 5y minus 4. That's it. So the lateral area of this is 2 pi times radius times height. okay? And so my volume will be from 1 to 4, the y goes from 1 to 4 of all this lateral area. And that's it. That's set up.